Okay, in my last integration by parts video, we learned a powerful method called tabular integration. Actually, let me just bring it back over here. Okay, here it is. And remember how I told you earlier that when I make my substitutions, I always like my u to be equal to some type of polynomial or the variable in here, you know, like the x or the y or whatever it happens to be. And then I like to take my dv and leave that to the cosine, the trig function, you know, the log, whatever, you know, other type of junk. Usually the junk, you know, is going to be the dv and the u's. But and we use integration by parts, okay, and eventually this x to the fifth goes away, and then we can, you know, we showed that by doing this. So repeated use of integration by parts, eventually the x goes away, it goes down to a constant or a zero, and then, you know, we can just sum up all the terms, okay, and that's our answer. Okay, but in this problem here, it's a little different because, just take a look here, this, we've got two different functions here, really. Okay, we've got e to the y and cosine y, and neither of them are going to go away. I can integrate and differentiate this e to the y all day, it never goes away. And really, this cosine y, it really doesn't go away either. I mean, it just alternates in between sine and negative cosine and sine, you know, and forever. So what do you do? Okay. Well, let's go back up here, and what's going to happen? Basically, what's going to happen? Let's say I have an algebraic expression here. Okay. The first thing I told you to solve this thing. One of the first things you'd probably do is say, well, there's the 2x's over there. Okay, well, I'll just add 2x to each side. Okay, and then I get 4x is equal to, maybe this wasn't an x. Let's say it was a, I don't know, let's say it was a q. Okay, I don't want to solve the whole thing. I just want to make a point here. Okay, well, notice how in our problem, you know, we noticed that we had two of the same items on each side. Okay, well, if I just move the 2x over algebraically, and here's my answer to that. You know, 4x is equal to this. Okay, and I could take it a little further, but you know, basically, we're going to use this technique here to find the answer when this happens, because you'll find out that these things never go away. And I did something a little different in this video than I normally do. I went ahead and I worked out the problem already. Okay, but I only worked out the stuff that we already know how to do. Okay, we've already went over this stuff in the other video. So just to recap, okay, here was the original function. Okay, it was this e to the y cosine y, and then I went ahead and I did my u, du's, and I did all that. Okay, I used integration by parts, and here's what I ended up with. And I put I know I'm going to have to use integration by parts again because I ended up with this ugly, you know, basically the same thing, just different function. Okay, so I knew I'd have to use integration by parts again, so I bracketized this, there's a negative sign, and I made my substitutions again. Okay, so I went ahead and I went through it again, just like, you know, we know how to do, and I came up with this expression. And then I decided I'm going to simplify it a little more, take care of these negative signs and some of that, and then I can lose the brackets. And then I ended up with this. Okay? Next thing I want to do, I'm just going to take this -1 and I'm going to pull it out of the integral because it's a constant. Okay? And then, guess what? Guess what happens? Here's our original guy right here. Okay? Well, if we pull this -1 out, it looks like we've pretty much got that guy, don't we? Okay? Well, here's the next simplification. And yes, that is exactly what happened. Okay? So we already know how to do all that stuff. Just repeated integration by parts. So now let's figure out what's going on here. Well, if I get the same thing over here as I get over here, I'm going to add it. Okay? So I'm going to add cosine x dx. I guess there should be an x in there, but you know what I mean. So e to the y, or actually it's y, I'm sorry, y y, y. Okay, cosine y. Okay, so now if I add what's integral of e to the y cosine y plus e to the y cosine y? Well, it's just 2. E to the y cosine y. I'm staring at this because I wrote I wrote coys. So okay, so now these cancel out, and I'm left with, let's just write what's left over, which is going to be this part right here. That's e to the y sine y plus e to the y cosine y. Okay. Now the next thing I could do, I could either just divide this whole thing by 1/2, or I could divide the whole thing by 2, or multiply it by 1/2. Take your pick, whatever works best for you. I think I'm just going to multiply the whole thing by 1/2, because that'll make this 2 go away, won't it? Okay, so we'll just bracketize this. Okay, so the 2's will cancel out, and that'll leave me just with the integral being equal to e to the y sine y plus e to the y cosine y divided by 2. And you can factor the e to the y out. I don't care if you do or not. And let's also put a plus c there. So basically, what happened, the main idea is, I think we ended up with this situation here. It's just when you first do it, you probably don't recognize it because you got the expression's very long. You got all these integral symbols here, and at least it wasn't obvious to me right away. I had to really think about it and work with some buddies before we figured out that, hey, we can move this thing over there. So just to review, okay, here's our original problem. And this is another situation to look for. And I guess you could call this the circular example, because it kind of seems to go in a circle, it seems to go nowhere. But when you see an integral, and you see that there's two functions make the thing up, and none of them go away, okay, via derivatives or integrals, usually you can go ahead and you're be prepared to use this technique, okay, because they're never going to go away, okay. Now if this is like an x to the 5th or something, the x to the 5th eventually would go away, like in our last example, and you could, do your tabular method and get away with it. So that is probably, I think the only other integration by parts thing. And after this, I'm going to make a little review video, and I'm basically gonna say, hey, this is what I would do in this situation, and hopefully, it'll help you out. So thanks for watching. I'll see you in the next video.